This is the video lesson for Chapter 1, Section 5. This is our third video lesson for Level 1. To open up the video lesson, we have a screen that is a pre-lesson quiz, material that we've already studied in the prior two video lessons. At this point in time, you can pause the video and look at these questions, come up with your answers. When you restart the video, I will mark up the correct answers and do a brief discussion of them so that we can move on into the new material. So you can pause the video now. Now, if you didn't pause the video, you're going to see the answers right now. If you did pause the video and solve your answers, now you can go over them and check. First, what comes next in the following pattern? 1, 2, 4, 7, 11. The correct answer was C, 16, because we were adding 1. Then add 2 to the previous number, add 3 to the previous number, add 4. 11 plus 5 is 16. 16 plus 6 would make 22, the number after that. Two planes intersect to form a line. Number 2, the correct answer was always. We know that this is a basic postulate for this class, that two planes come together always to form a line. 4 points are coplanar. We said sometimes. And then you're supposed to be prepared to give an example. So my example would be points E, F, B, and A are coplanar. That's sometimes they are. Points A, E, F, and G are not coplanar. Sometimes they are not. Number 4, which of the following is parallel to plane AED? Well, AED is the side plane here. So I look to the other side plane, F, G, C, and B. These are the letters I would like to work with. F, G, C would describe this side. What is the fourth point on plane HGC? HGC looks like the back, and point D. Whoa, that didn't circle correctly, but point D was the answer. And finally, we just had a little bit of algebraic work. Did our solving go well? And in this case, it was D. W equaled -1. So let's get going on Chapter 1, Section 5. Segments and angles. Today we're only going to look at the video of segments. Angles is actually going to be Chapter 1, Section 6 on the next video. First, we're going to talk about the idea of measuring segments. In the previous video lesson, we mentioned that segments are finite and they're the first thing that we can measure. In order to look at measurements, we're going to talk about distance. And distance is going to talk about difference. Difference being subtraction. So we come with this idea that says, on a line, points can be given numbers. For example, let's say A is the number 2 and B is the number 7, and we're applying units to this. Could be inches, could be miles. So this helps us find the distance between these 2 points, just like on a number line. So we could say the distance between point A and point B is 5 units. Now this is found because that is the difference between the number 7 and the number 2. So if you do 7 minus 2, you get 5. Interestingly, if you do 2 minus 7, you end up with -5. And we're going to discuss how that can still be seen as distance. It does not matter what direction the line goes in. If the 2 is here and the 7 is here, then this is still 5 units away. So, what about that negative that we ran into? What we can do is by saying if 2 and 7, the distance becomes the absolute value of the difference. That way, no matter what order we subtract them, if we take the absolute value, which is the positive or the distance from 0, and a distance cannot be negative. You don't ask someone, how far do you live from Poway High School? And have them point and say, I live -5 miles that way. Or I live -2 miles that way. No, distances are not negative. So an absolute value is just a distance from 0. -5 is still 5 spaces away from 0, just to the left rather than to the right. So if we take the absolute value of a subtraction, we will always produce a distance. An example would be if QS, find QS if the coordinates of Q is -3 and the coordinate of S is 21. Notice QS has no line symbol or segment symbol. Without those, this is read, find the distance of QS. So from -3 to 21, what is the difference? Now, we go to -3 minus 21 would be -24. The distance of that is 24 spaces. Had we done it the other way around, 21 minus -3, we would have ended up with the absolute value of 24, which is also 24. The distance between -3 as a number and 21 as a number is 24 spaces. So, distance is difference. We want to remember that. Now, two segments with the same length are congruent. This is the symbol for congruent. It is an equal sign with a squiggle on top, for lack of a better term right now. It's the similarity symbol. What it really means is they have equal length and similar shape. There are two requirements to be congruent. You must have the same shape and the same size. But when we're talking about segments, all that really matters is that they have the same length or size, because you can't have a different shape. Now, we have to be careful. This says the distance from A to B is equal to the distance from C to D. Notice it says equal. It doesn't say congruent, because this is referring to numbers such as 2 equals 2. Now, that means lengths are equal. If I want to call them segments, I put the segment symbol on top. Segment AB is congruent to segment CD. Now I'm talking about the names of the segments. And so I am saying that shape, that object, is exactly the same as the other object. And I have these markings. The fact that there are two markings does not have to do with this two. It's the idea that they have the same number of markings. If I was to put 3 segments on the board, here's AB, CD, and I put up EF. If I was to mark 1, 1, and 2, my markings suggest that AB is congruent to CD, but not necessarily exactly the same as EF. EF is implied here to potentially be different. It's not saying it's a guarantee it's different, but we can guarantee these are the same. So, lengths are equal, segments are congruent. This is just how we speak and how we read through things. Numbers are not congruent. Numbers like 2 is equal to 2. This segment is the same shape as that segment. Okay, the segment addition postulate. This is, remember, a postulate is an accepted statement of fact. We are saying that if 3 points, A, B, and C are collinear, straight line, and B is somewhere in between A and C, then if we add the distance from A to B plus the distance from B to C, we get the distance from A to C. I like to shorten up the segment addition postulate by having you write down that the best way to remember is part plus part equals whole. If you take the 2 parts that are in line with each other, add the 2 parts together, you get the distance of the whole. Part plus part equals whole. An example of how this might be used in an algebraic method would be if we are told the distance from D to T is 60, and this distance from D to S is 2x minus 8, and the distance from S to T is 3x minus 12, how can we figure out the value for x? Now, I'm not going to jump around or jump steps here. I want to show you guys everything. The first thing geometry teaches us is we know the distance from D to S plus the distance from S to T equals the distance from D to T. That is what the segment addition postulate fact tells us is acceptable and true. Next, I will write that 2x minus 8, which I have now substituted because ds was a number, and I have substituted a new version or a new look for that number. St is 3x minus 12, so I will substitute that. and 60 is dt. I will substitute that. So substitution allows me to place the number values into our geometric equation. At this point, I'll combine my like terms. I have my 2x and plus 3x, so that's 5x, and negative 8 minus 12 is negative 20. We'll then use the addition property, which states if we add the same thing to both sides of an equation, the equation stays true. So if we add 20 to both sides, negative 20 plus 20 will eliminate, but 60 plus 20 will become 80. The equation maintains its truth value. And then we use the division property stating the same thing. If we divide both sides by 5, the equation will remain true. So x equals 16 is now our final true statement. We have solved for x. We still need to find ds and st. We use substitution once again. ds is 2 times 16 minus 8, which becomes 32 minus 8, which is 24. And we have 3 times 16, which is 48, minus 12, which becomes 36. Confirmation that we are correct is that 24 plus 36 equals 60. That's our sample problem for how to work with the segment addition postulate. Next up is a midpoint. We talked about the fact that a segment actually can have a midpoint because it is a finite distance. So here we define a midpoint as a point that divides a segment into two congruent segments. So let's put a picture of this. Here is a picture that shows us there is a midpoint, point M. Now, there are two different ways this could come out. We could first say that if the two parts are congruent, then M is the midpoint of the segment. That would be if I was to place this picture on the board in this order, A, B, put M, and I mark these congruent. You could raise your hand and say, that means M is the midpoint. That would be where we'd go. We'd say, therefore, M is the midpoint. However, the second statement says, what if you're told M is the midpoint first? We draw A, we draw B. Here's point M, and we say, this is the midpoint of AB. We will then mark these, and these markings are our conclusion. So it's important to make note that it doesn't matter which one comes first. Either you're told it's the midpoint and then you mark the parts congruent, or you're told the parts are congruent, which create the midpoint. This ends up being called a biconditional, which we'll study in level 2. A definition, a very good definition, will always be biconditional. It will always be able to be reversed. Now, if M is the midpoint of AB and B is the midpoint of MC, then AM is congruent to BC. Is this a true statement? If we are told that M is the midpoint of AB, we could write this down. Well, segment AM is congruent to segment BM. Now we have the second statement that we also know. And we know that segment BM is congruent to segment C or BC. We are told, we know each of these because of the fact that we are told they are midpoints. We could write here, AM is congruent to segment BM because M is the midpoint. BM is congruent to segment BC because B is the midpoint of segment MC. We need to learn to say those things and write it that way. So then what we notice is that AM is congruent to BM, BM is congruent to BC, segment BC. when asked the question, is it true that AM is congruent to BC? What is our best description? True because all segments are congruent? True because they are both congruent to segment MB? Is it false because actually they could be different lengths and we have not proven it? Or is it false because no segments are ever congruent? The correct answer is B. And it would be great if we recognize and remember from algebra that we can now say segment AM is congruent to segment BC because of the transitive property. And the transitive property of mathematics tells us that if two things are congruent to or equal to the same thing, then they must be congruent or equal to each other. AM is congruent to BM, BC is congruent to BM, so therefore these two must be congruent to each other. Now, here are some problems for today. These are the examples that are much more algebraic based. We did see one example earlier of the segment addition, which will help you for segments 1 and 2. But when we jump over to number 3, I want you to notice these are each individual problems. So, when it says in number 3 that B is the midpoint, that is the first time that B is the midpoint. It is not the midpoint for these two problems. But on this one, when you draw ABC, it is very important that for number 3 and number 4, you mark AB congruent to BC. Mark that to yourself. AB is congruent to BC. And then remember that that means AB is equal to BC. This is important so that you can use substitution. You have two equations. AB is equal to BC, and we know that AB plus BC equals AC. We can use all of these things and substitution in order to figure this problem out. These are numbers. AB is 2x plus 11. BC is 5x plus 8. Here we would have a full equation. If I put in 2x plus 11 and 5x plus 8, equals what? I don't know what to set this equal to. I don't have an AC. They have not given me an AC. But on this equation, we can solve this. And once we solve this, we can substitute into this equation. That's your hint to get started with those problems. And that's what we'll be spending our time on in class when we come back to look at Chapter 1, Section 5. At this point, you can pause the video and finish doing all of your work, and we will check our answers when we come back to class.